All right, I think we will get rolling. I'm Todd Zimmerman. I'm the Collaboration Coordinator for WestGrid. I'd like to welcome you all to this semester's WestGrid Seminar Series. We have a bunch of good talks planned for this semester, 5 talks actually coming up. This is the first of the 5. And today's talk will be the Intro to WestGrid, Tips for Choosing a System and Running Jobs. It's going to be presented by Roman Baranowski from the University of British Columbia. Roman is the site lead for WestGrid at UBC, and he runs systems such as Glacier and Orsinus. And he's going to tell us some tips for choosing a system and running jobs on WestGrid. Roman.
Okay, so Roman, that's me. So good morning, everybody here. Good morning, everybody in BC, and good afternoon to everybody in the rest of the country. Okay, you are already in the afternoon. So as Todd introduced me, my name is Roman Baranowski. I am the site lead of WestGrid here at UBC. And today we will be talking about WestGrid overall, Compute Canada, how to basically start your computations on our resources. Okay, I believe it should be working. Nope. Okay, yeah. So WestGrid is a part of a much bigger organization. We are part of the Compute Canada. In order to get access to resources within WestGrid and Compute Canada, the first step is basically that you have to register with the site. That's okay. I am still there, and the presentation is over there. So in order to get access to our resources, you will have to register with the Compute Canada. And this is a very nice site. You can explore this website. They have plenty of new information. They have plenty of info, what's happening within the country, within the organization, where we are heading, what is our mandate, and how we will be operating in the near future. So again, go to if you need an access to WestGrid or Compute Canada resources, you have to first register with the Compute Canada. And after registration with the Compute Canada, you will have an account there, and you have to link this account then with any particular consortia. So there will be a link when you log into the Compute Canada. There will be a link to link your Compute Canada with the account with WestGrid. So within WestGrid spans 4 provinces, starting from BC and ending in Manitoba. That's why we are called WestGrid, not Compute Canada, because we only go to Manitoba. And in all 4 provinces, we have some computational resources. Altogether, when we add up everything we have in WestGrid, this will be roughly 40,000 computational cores and approximately 10 petabytes of storage space. So again, if you are not sure which system is good for you, please visit the WestGrid webpage. And if you go to the support and systems, there is a huge list of the resources we have. I just here pointed out only the first entry there. That's the system which is called Breezy. It's located at the University of Calgary. That's the number of cores it has, and what is the type of this, and then a little bit more details. What is the interconnect? What is the file system? How much memory we have per node, and so on and so on. If you would click on Breezy again, you will have a much more detailed specification about the system, how to use it, what are the best practices, or what is the setup for this system. So in addition to this computational course, you will find there that we are right now offering a storage, sharing storage like a cloud solution. And also we are offering, very soon, we will be offering the OpenStack platform for everybody. Now, how to connect to WestGrid? So if you, the only way to connect to the WestGrid is using the SSH-based tools. And if you are working, if you are sitting on a Linux box or the Mac OS system, the SSH tools are basically built into already into the operating system, so you shouldn't have any problems connecting to the WestGrid. If you are a Windows user, you need to install a little bit of additional software. And again, if you go to the WestGrid webpage and you will type how to connect to WestGrid, there will be the entire section describing what steps have to be done and how it has to be done. I'm just mentioning here that you can use WinSCP, put PuTTY, and if you need the X application, then you have to install Xming or Cygwin. There is a new right now nice piece of software which is called Moab Xterm, or eventually you can find Bitwise SSH client. Again, it's pretty useful. You have quite a lot of information on our webpage with the detailed stuff how to really use that and how to do that. Then, of course, you will have to put your data to our system. So you can use, again, SCP, which stands for the secure copy. This is the part of SSH package. And, of course, you can also use the Globus tools like GCP to move the files between the sites. And, of course, you can also register with the globus.org. And when you register with the globus.org, you will be able to use graphical tools to move the files between your desktop and WestGrid resources, or between different WestGrid systems. Okay. So here I have to mention that this is quite important when you are applying for the computational account with Compute Canada. You have to provide your email address. And since we are using certificates, and the certification agency which issues us certificates is called Grid Canada, and they are not accepting any generic mail. So they are insisting, in order to have a better management of your identity, they are insisting that the email address which we are registering with should be institutional. So don't use Gmail, don't use Yahoo, don't use anything like generic email like short Yahoo. Use your university email. Okay, so this please use UBC or any other university email you are placed in. So when you log into the system, you will be placed in your home directory. And this home directory brings us to the issue that right now you are sitting on a global file system which is native to the cluster you are working with. And we are, across WestGrid, we are using 3 types of global file system. The most popular is Lustre, but we are also using GPFS, which stands for the General Parallel File System. And in some sites, we are using the Ibrix file system. These file systems are quite complicated beasts to manage, but we are trying to do our best to keep the systems up and running and to have the smallest possible idle time or downtime whenever we have the issues. On every single system within WestGrid, we are introducing quotas. So basically, you have a limited number of files and a limited number of space. Then again, more detail are listed on our webpage. Right, every system has slightly different number of files, slightly different amount of disk space depending on the total capacity of the file system you are working with. And I immediately make a pledge here that whenever you are working on WestGrid systems or any cluster with the global file system, like Lustre, Ibrix, or GPFS, please avoid creating many small files. because the performance of this file system then basically very quickly degrades and it's not effective. So small files are always a killer for this type of file system. They are tuned up for the larger set of data. Now, of course, right now, choosing the system you would like to work with, the most important is what software is available on a given system. And then again, on the WestGrid web page, in the support software, we have a list of the software which is installed and available on our systems with the information on which system, what version is installed. Of course, you can always ask us to install this software, or you can build your own software in your home directory. Right? The systems are open for everybody to use. Most systems you will find, if you are not interested in browsing the web page, you can just log into the system and check the directories, user local, what's installed there, or global software in most of the cases. Then, user, when you logged in, not every software is immediately available to you. In order to set the environment, let's say for GROMACS or for VASP or any other type of packages, very often it's controlled by the modules. So again, on the support page, there is an entire section how to use modules, what they are, how to use them, what are they, how to basically work with them. Very simple commands. I just listed there 3 very simple commands. So if you type the module available, it will list you all the packages which are available on a given system. And then, of course, if you would like to use any of these modules to set your environment, you simply type module load and the name of the module. If you would like to switch between the versions of the software, you have to do module load. And then if you are not interested in this anymore and you would like to switch to another version, you will simply unload this module and then load the other one. Now, you have already logged into the system and you can start working interactively. You can start editing. You can do the transferring files between your desktop and the system. You can start working with your code, looking for what's going on. Or you can do some data analysis because you have, let's say we have a software which you need to perform your analysis. And you can do also testing. So when you are logged in, you are basically connected to nothing else but a little bit more beefy desktop. That's a simply login nodes or head nodes. That's the terminology. So this is used by the multiple users. So if you can run for a short period of time on a head node. However, the entire computational engine is just behind. So the system you logged in is your head node, and at that time you are not even using any computational engine we are providing behind our head node. So in order to if you would like to work interactively and use the computational engine, you can basically submit the option, submit a job, which I will be talking in a second, with the option Q-sub-I. Q-sub-I, depending now on the resources available on a given cluster, you will have to wait some period of time till this job starts. So if you type Q-sub-I, you will put some options there, which we will talk in a moment, and you will submit your script. Then you will simply have to wait, and at one moment when the resources are available, you will simply be connected to one of the computational nodes on which all the other resources you have specified will be allocated for you. So here we are coming to the queuing system, right? The queuing system and resource management. So queuing system basically comprises of 2 elements. This is a resource manager, plus the scheduler. In most of the cases, our resource manager is a Torque, and basically Torque works all the time scanning and keeping track which jobs are running, which resources are available, how much given job takes memory, which nodes are being occupied by a given job, and reports everything to the scheduler. And the scheduler, in most of our cases, is just a Moab scheduler. And Moab is responsible, Moab is also working all the time, trying to figure out which jobs have to be started next, which jobs have to run. And in terms of our queuing system, we are using so-called Fersher targets or Fersher tree. So basically, every user, we are trying to make the system fair to everybody. Okay. So here we are coming to what is the job script. So job script is usually incredibly simple. It can be simple, it can be more complicated, but this is basically an ASCII file, a text file, in which you are specifying what you really would like to do on the system. So the first line of this is basically that we will be running everything under the bash shell. And then everything which starts with this hash PPS is basically a directive to Torque saying what kind of resources I would like to use. So PPS-N is basically, that's the name of my job. I would like to run, let's say, Gromax suite. So I'm calling this job Gromax parallel test. And then the next line is very interesting and important. Basically, I am specifying what kind of resources I would like to use. So in this line, I am asking for 48 processors. And this 48 processors means that I am not interested in any particular geometry of this job. I would like simply to grab first 48 available processes on the system. Then I am specifying the wall time, and in this time, wall time is this means 12 hours, right? So hours, minutes, seconds. And then again, if you logged into the WestGrid support pages and you look at the specification for every site, some sites have a very long wall time, which is allowed. Some sites have a very short wall time. So you have to be aware of this as well. And the third line, the third entry, PMEM, is basically how much memory I would like to use per process. Right, so I am specifying that I would like to use 1 gig of memory. And then again, very often, if you need a lot of memory, it's better to use keywords megabytes, because all of our systems, there's some memory reserved for the operating system and for the system processes. So even nominally, let's say the node has 24 gigs of memory, not all memory is available. So if you specify that I would like to use 24 gigs of memory, it's possible that we will not be able to find such a node because there is no 24 gigs available. But if you specify 24,000 megabytes, that's possible. Then for the next lines, I basically are saying that I would like to join output and standard output and standard error. The next line is basically specifying that all the mail which will be generated by Torque or Moab regarding this job should be sent to me. That's my email address. And then the last line, the last directive basically says that if I am interested in a notification and information about my job at the beginning, that's B, E is end and A is abort. So basically, send me an email. In this line, I am asking system, please send me an email when my job starts, when my job's finished, or if anything goes wrong. If you have aborted the job, please send me the information. So these are the directives, and that's the end of the job specification section. I'm sorry. And then basically you are saying what you would like to do. So this is an MPI run. But everything basically depends on your code, on your approach, what you would like to do. You have to write such a script on your own. If you need help, again, we are around and you can contact us anytime. So very briefly, a few specifics, comments about within the talk and Moab. So QSub script basically submits the job. So that's the job script I just described. When you type QSub, this will basically submit your job to the queue. If you type show queue command, the show queue will scan all the jobs on the system and will show you what's happening right now within the given cluster. If you are interested in when your job will start, you can always use the command show start and the job ID which belongs to you, and the system will try to estimate how soon your job will be in the queue. Show VF basically shows the backfill window. So it basically tells you what kind of a job should be starting at any given moment of time, what is available. If you are interested about specifics about any particular job, you can use the option QStat and then the option -F. If you are not interested in any, let's say you submitted a job and you decided that you don't need this job anymore, the job is sitting in the queue, but you would like just to delete this job, you just basically type qdel and then again job ID of your job. Now, if you would like to monitor your jobs, please again visit this webpage, our webpage, running jobs. And as I said, you can specify this PBS -M and capital M with your email address, or and PBS -lowercase m information. So then when the job will finish, it will send you the information about how your job was doing. There's also documentation how to use the epilogue script, which will give you much more detailed information about your performance and your footprint. Or you can also do the QStat lowercase f, and your job ID. It will print you if the job is running. It will give you the information on which nodes it's running, how much memory it's using, what is already wall time used, how much wall time have been left, etc., etc. And of course, if you can also log in directly to the compute node. So QStat -F will provide you the information on which compute nodes your job is running. You can log in directly to these compute nodes and just use standard Unix command to see what your job is, how your job is performing, what is happening. And basically, I believe that I will be. So, how to choose your system? So first of all, you have to scan the list of what is available. Maybe your computation needs just an ordinary cluster. Maybe they can run nicely on shared memory machine, or maybe they need a large shared memory machine. So the first step when you are moving to WestGrid is basically go very carefully with the list of our resources. Think about this, what you would like to do. If you are not sure what is the scope of your work, please visit us at every given site of WestGrid. Whenever you are, there is always a person who you can talk directly. So at UBC, that's Brent and me. So you can give us a call, drop to our office. We are located in chemistry. We can talk about this in a moment. In every other site, there is always a person who will have some time, resources, and knowledge to start going. Okay, so don't be Don't be shy. If you need help or if you are not sure, you can email us, you can call us, or you can just even show up in person. The general strategy is basically try your runs on the different systems, see which systems best suits you, on which systems you feel most comfortable, if which system has the proper version of the software you would like to use, and start testing with the small subset of data, with the small subset of a problem. If you don't know how really code scales, and now if you submit a job which immediately asks for, let's say, 1,000 or 500 of this amount of calls, and this job has some flaw inside, it will basically confuse the queuing system, and you will be wasting time. We will be wasting time. It will not be effective. So whenever you are choosing, you have chosen a system, try small, and then start growing when you are getting the confidence what you really need. Also, if your job runs 5 minutes, don't ask for. If you know that your jobs run let's say 10, 15 minutes, don't ask for the maximum wall time available, because then again, the scheduler has to find the resources. You are asking for, let's say, 10 days of computational time. So the scheduler has to make the reservation for 10 days. And then your job starts, runs 5 minutes, and it's done. If you specify that you would like to use, instead of 10 days, 1 hour, your job will start much, much faster, because we can use so-called backfill. Right? So there is in a QA job which is ask for many resources in a long time, and I am starting to harvest the resources for this job. But again, since I'm harvesting and keeping some nodes idle, if I'm asking for a short wall time, your job will go quickly down. When you see that your waiting times are very long, or you really need much more resources, you have to apply for the resource allocation. Usually it has to be done by the principal investigator, and the resource allocation committee works once a year. We just finished our allocation right now, so it runs from January till December. But of course, there is something which is called out of round allocation. So in the middle of the year, if you think that you need much more resources, please talk to your supervisor, and he can apply online for the resource allocation. Okay. So that's my summary. I believe that I already touched most of this stuff. Now, so we will right now, in a moment, I will be able to answer any of your questions. And then I believe the idea is that we will break from our global seminar, and local support person will be able to answer some of the questions you have at every single site. So again, most of the information you can find is basically on our support page. If you cannot log to the system, please always check the system notices. We are trying to update them as quickly as possible if any issues arises. Sometimes that's a network connectivity. Sometimes one of our systems goes down because we have some issues. It can be power, it can be chiller. You can so please visit the system notices if you cannot log in. And if you have any questions, small or big, always write to the support at WestGrid.ca. We have a knowledgeable and diverse team of people around. So if I cannot answer your question, someone within WestGrid definitely will. Okay, we will find someone who is definitely knowledgeable in this area. You need help. And of course, if you call us, Most likely, we will say that today is impossible, but maybe never is good for you. Okay? So thanks a lot. I will take your questions right now.
So, are there any questions locally in UBC first? Any questions? Okay, so none locally. And are there any questions at other remote sites? You let the technical person in your room know, and they can pass it on to the text chat. And maybe a couple of minutes just to go through and see if there's any questions.
Do we have any questions anywhere? Any sites? It looks like Calgary's got a question.
Hi. You said that for testing, we can also run short jobs on the head node, so we don't have to use the QM system for it.
Roman, I don't know if you heard that. It was pretty quiet. He was asking about testing short jobs on the head node, I believe was the sum of the question.
Yes, so in principle, the short runs on a head nodes are allowed, but please limit your time of running to 15 minutes, half an hour at most. But I really strongly suggest this option of submitting interactive job, because right now, if you are logged into the head nodes, you are sharing these resources with everybody around. People can be moving data, people can be editing. So when you are starting to run your jobs, and everybody will start to run the jobs on the head node, this head node then becomes unresponsive and is basically unusable for everybody. In addition to this, the head nodes are very often configured slightly differently with more software than the computational nodes. So when you are running on a head node, your environment can be slightly different, or the working environment or the software layer can be slightly different than computational node, so you are not able to detect, let's say, I am missing some library, I am missing some package, or some environmental variable hasn't been defined for me. It's always better to just go directly to the node, because your Q sub minus R and interactive work on a computational node basically will be exactly the same environment and exactly the same type of the performance as you will get in a batch system when you submit the job to run in a batch. Okay?
Okay, so I think there's a question from UNBC. If you want to go ahead.
Hi. I have a question about usage of WestGrid resources with next-generation sequencing data. We are currently working with these types of data sets and have sort of sent our jobs to Genome Quebec, which is using a Calcul Canada HPC node for some of this analysis. But we did notice that with respect to their troubleshooting, the wall times and RAM allocations do tend to get rather large with our data sets because they are quite complex. And my question is whether there are support personnel at WestGrid who have more experience with this sort of data set and the idiosyncrasies that accompany it. The pipelines that are commonly used, some of them are actually installed on WestGrid, but they're not efficient for clustering. And we don't expect that we can make refinements for that. That is not our expertise. So can you comment on the availability of support from WestGrid for...
Okay, I'm not sure if I fully understand. It was not.
I think it was something fast. Sorry, you were a little bit quiet.
You were a little bit too quiet.
Okay, sorry. DNA sequencing data sets, do you have support personnel who have expertise with processing these?
sequencing data sets we have.
Support for DNA?
Yeah, we have expertise.
Yeah, yes, we do. So, because one of the sites within WestGrid is genome of PC.
The Genome Sciences Center. Yeah.
Right. So we can always tap their resources. If we lack the expertise, computational expertise in this particular area, we can always tap to their resources and ask them. So then again, a question. Please just give us a call or send us an email, and we will. If I am not able to answer your question, or if anybody in University of Northern British Columbia is not able to answer your question, we will try to find you the best resources and the best support.
Okay. Thank you.
Okay.
Looks like Calgary has another question. Calgary, could you be close to the mic? You're a bit quiet for the rest of us. Thanks.
Yeah, actually, I'm sitting closest to the mic. So far we've heard about software installation saved either globally or in the present context. Install software, share with your collaborators.
Sorry, Calgary. We're getting a lot of artifact noise. So your question started with installing software locally or by other means, I think. Could you continue?
So far, what I've heard is one can request software to be globally available, or you install it in your own home. It's possible that you do something in between, say that one knowledgeable collaborator installs software that is then being shared between other homes.
So let's yes, we have this ability because we can always you can share your directory within a group, with a collaborative group. So let's say if a person A has one piece of software, person B has a second piece of software, and they both would like to share their software, yes, it's possible. We are basically creating a shared group, and so again, if you visit our documentation pages and look for the sharing accounts, it's possible.
Okay, we have one more question at UBC. Go ahead.
You talked earlier, first of all, I'm not a ComSci expert, but I do work very closely with our ComSci person. My question is, you mentioned small files are something that you don't really like. One of our projects requires essentially large files to be broken down into about 1 million small files, sorted, reconstituted, and basically there's a constant breaking down, resorting, breaking down, resorting of large files into small files. Is this a whole big problem for you guys? Like, what do you mean when you say that you guys don't like small files?
We don't. Because let me explain this. The global file system, this is basically a network file system. So every transaction, every opening of file, every open file, read file, write to the file, this is a network transaction. Okay, we have a fast interconnect. That's usually DDR or QDR, or right now maybe it will be even FDR. So that's a fiber optic, but that's still a network transaction. So you are going multiple steps over our internal network to get to your file. So writing small files, so we are introducing huge traffic. So there is a latency, there is a huge latency accessing small files. There is a huge latency writing small files. And so that's basically a network operation. So if you really need to work with the small files, every single computational node has its own local bit. So if you would like to do the assembly, move your data in the very beginning of your job from your global file system, from your home or from your scratch, to the local disk on the compute nodes, which is usually what's 200.
Between 120.
Between 100 and 200 gigabytes. So move your data to a local disk, which will be basically then like you're sitting on your laptop or your desktop. Do all the manipulations with this because, first of all, this is a ext4 file system. So it behaves much more naturally working with the small files. Do all your combinations, whatever you are doing, on a local disk, then you will not have a latency. You will not have any issue of the performance of the file system. Do all this work there and then move everything back. This will be much more effective. Your job will run faster. You will not be getting nasty emails from us that you are slowing down us and everybody is suffering. Please, what are you doing? Okay?
Okay, thank you.
Okay, if there are no other questions at the remote sites, I guess we just thank the speaker and you can ask your local technical staff any other questions that you didn't get answered yet. Okay, so thank you, Roman.
Thanks.